Welcome, everyone. Thank you so much for joining us for the last episode of our Building Retrofit series for owners and operators. My name is Rimjim Agrawal, and I am the Program Manager at Illinois Green Alliance, managing the programs and partnerships at the Building Energy Hub. We're excited to have you all here for the final episode of our three-part series. And if you haven't watched the other episodes, I'm going to share with you a little bit about what they were in a little bit. But before we go into the webinar, I would love to talk to you a little bit about who the Hub is and what we do. The Building Energy Hub is Illinois' trusted resource center for building professionals seeking practical solutions to improve building performance. We created the Hub and its educational programs to help commercial and multifamily building owners, developers, operators, property managers, contractors, and municipal and community partners with planning, financing, and implementing building retrofits within Illinois. The Hub provides practical approaches to meet energy efficiency compliance requirements, clear pathways to performance and energy efficiency improvements, access to funding resources and incentive programs for building energy efficiency, and real-world examples of successful energy efficiency implementation. Some of these things that you're going to see today. Next slide, please. The three-part Start Here, a building retrofit series for owners and operators is meant to guide you through the three steps of the decarbonization process. The first episode talked a little bit about why decarbonization matters, why you should pursue it, and why it makes good business sense. The second episode talked about how you can strategize decarbonization and how you can plan for action. And today's program will talk about how you can turn those planned steps into action and how you can implement those. This session will dive into real-world implementation pathways that turn plans into results with examples of successful retrofit projects and the partners, tools, and funding strategies that made them possible. But before we go into today's webinar content, we'd love to learn a little bit about who you are. I'm going to launch a poll that will now show up on your screen, and we'd love if you could share a little bit about what kind of perspectives you represent, and this will help our speakers speak more to your interests. Great. I'm seeing a lot of people want to learn about how to move from decarbonization plans to real-world implementation, which retrofit upgrades make the biggest impact, how to pay for retrofits using incentives and grants, and real-world examples and case studies. Thank you for participating. I'm just going to share these results with you all so you can look at these too. And we're going to go into the other question, which is which industry you represent. And if you would like to share more about what you do specifically, you could put your job titles in the chat as well. Great, thank you for participating. We're seeing lots of architects, some consultants, some developers, engineers, government, nonprofit, and real estate folks. So awesome. Thank you for participating in these polls. Just a couple of housekeeping notes before we dive into the presentation. If you have any questions during the presentation for our speakers, please put them in the Q&A or in the chat, whichever you prefer. We will be recording this session and posting this to the Illinois Green Alliance YouTube channel, and we'll be following up in an email about the details from this presentation with the slide deck as well as the recording link. With that, I'd love to tell you about the speakers we have today. We are joined today, next slide please, We are joined by Jamie Johnson, Matt Zwiebrick, and Maya Coyle, three amazing speakers who will talk to us about different building types and the projects that they've implemented, the real world implementation, the challenges that they faced, and the lessons learned from these. And then we'll be diving into more of a panel style discussion and learning about the things that they've learned and the higher impact improvements that they recommend. So, with that, I'll introduce Jamie Johnson. Jamie Johnson is the founder and CEO of Verde Energy Efficiency Expert. Verde specializes on finding and implementing energy efficiency measures in Chicagoland, including LED lighting, EV car charging, ashtray audits, and heat pump implementation projects, which is what Jamie's going to talk to us about today. Jamie also lectures at the Harris School of Public Policy at the University of Chicago on the market implications of environmental policy. We're excited to have you with us, Jamie, today, and thank you for sharing your time. I'll turn it over to you.
Thank you very much. Excited to talk about this topic. Just to give everyone a perspective of where I come from, I was a firefighter for about 10 years, always passionate about energy efficiency, and so went back to grad school at the Harris School, where Rim Jim and I both attended, and then I learned about a lot about policy and started a company to implement some of the ideas that I had. So I just give that as perspective, as that I don't have a ton of formal training in this space. I'm self-taught, and I've gone through some painful lessons, but also some amazing lessons too. So, the pros of decarbonization, I think this group probably knows a lot of it, but I just thought I would highlight it. Where I find a lot of promising opportunity for decarbonization is around steam boiler replacements. It's just a big pain point, and there's not a lot of easy ways to retrofit. Things like rooftop units are harder to do because the infrastructure's more modern, and a lot of the infrastructure is already in place. So changing it to something like a VRF is very difficult from my experience. But a lot of the pros that we see from our past projects are the air quality and the comfort in a space is just so much better with decarb than it was with existing forms. I always find natural gas heating to be everything is equally uncomfortable everywhere. Whereas a VRF, you can get it really modular and granular to each room and space, and it's a far better system. It comes with a much higher cost. And some of the cons are the biggest one I want to highlight, and I think to some folks it's obvious, but it's still trying to grapple with this on a policy level, is that sometimes switching to decarb does not provide an ROI. Doesn't mean that it doesn't provide it in 50 or 100 years. It never can provide it, and that's because natural gas is incredibly cheap as a fuel source. That's been exacerbated the last few years as electricity rates has gone up. So it makes it difficult, as well as the start-stop of federal incentives, which have come and gone. Even utility rebates have kind of peaked into the program development phase and the research phase, but they haven't really systemically rolled out into the marketplace yet. And it's painful to retrofit old buildings, and I will talk a little bit about that on my next slide, please. So this is my first foray. We had done at my company, we had done probably a couple thousand buildings of retrofits, mostly lighting, some a couple hundred rooftop unit replacements where we take an inefficient unit off and put a slightly more efficient unit on. Those were fun. We learned a lot, but going deeper into decarb has always been our passion. This project started in 2021, completed in 2023. Huge savings in terms of BTUs of energy. They had a boiler system. They had a lot of old rooftop units on their roof. The building had been built and then added onto over the years. It's a beautiful building, great space, great community, super aligned with desires for sustainability. And it was a lot of work, a lot more budget than we expected, a lot of delays on products, a lot of difficult work. My worst days were my days of watching these heavy units. We had all kinds of structural engineers verifying everything and making sure that the buildings could sustain the weights and the placement, but watching them get placed was like two of my worst days. The crane lifts were also very, very long lifts, just the way the building was laid out. But 60% energy savings, kilobit kBTUs of electricity and natural gas kind of levelized, and Slipstream did that locally, but cost savings was not there because natural gas is incredibly cheap way to provide heat. We did have a water cooled chiller, so there was a lot of water savings that added to the project, but still, what happens next, the next 10 to 15 years in terms of electricity costs and natural gas will really look back and retroactively tell us whether this was a good ROI project. It didn't totally matter in this case because the community was behind it. But I think that's the real challenge I've faced in selling more of these projects is whether it truly has an ROI behind it or not. That's other than sustainability. Next slides, please. I did have to Google just to make sure, but we were in OSHA compliance on this one. But this is a Wendy's in Manuka. Really interesting project. The one thing I'll say about fast food restaurant, I work a lot with McDonald's, a decent amount with Culver's, and a lot of other fast food chains. Makeup air is really hard in a restaurant. There's a lot of CFMs flowing out of the exhaust, for good reason. But bringing in that much CFMs and trying to heat it through natural gas is a real challenge. This project was the most fascinating part for me. This isn't fascinating, but this is where my anxiety as a firefighter and a safety person kind of came into play. But there was plans to put like a 3 or 4,000 pound RTU on top of this building to replace something that was a fifth of the size, with very little framing up there. You could see some of the framework up in the roof. It just wasn't going to work, but there were so many folks along the way that dismissed that as a problem. And I finally had to throw my hands up and say, stop. Like, we're not doing this right now. We have to get structural involved. And it came back that it couldn't support the weight. And that was a pretty interesting makeup air unit. It was a air source heat pump, dual fuel. No, it was not dual fuel, I don't believe. It might have been dual fuel, but it was a heat pump makeup air unit, and just the size and complexity of it, it was too much for this building with the amount of CFM coming out. So I thought that was a pretty painful learning lesson, but this building was, after the project was done, was night and day more comfortable afterwards. So again, whether ROI is there or not, the complexity of doing it or not the question, the benefit afterwards were really there in terms of comfort for the staff and the patrons. Next slide, please. This was a kind of a passion project last year. I went to Norway with the National Guard. I have not found implications for this technology in Illinois yet, but I'm still working on it. But essentially, these are a CO2 heat pump, very forward in Norway in terms of using this natural refrigerant. In their history, I think 30 years, they've had these CO2 heat pumps in place in grocery stores, places where there's a lot of cooling. There was even a library that used the space out front to create an ice rink, and that cooling was then used to heat the inside of the building. This is a cucumber farm on the left. My daughter and I visited this. It was a trip of a lifetime, and it's inspiring to see, you know, a group of folks or society adopting change faster than we have. Norway, if you're not familiar, has about 95% of new vehicles are EVs. Again, much more advanced. There's a reason why a lot of it, and I won't spend too much time on that, but they have a much higher amount of electric resistance and electric boilers in the country based on their strong production of electricity. And so CO2 heat pumps just made sense because we're not fuel switching from natural gas to electric. We're going from electric heating to heat pumps, which are far more efficient. Next slide, please. I'm trying to, that previous slide, though, I will just note that I see a promise for that in breweries, and other like larger, more complex places in Illinois where there's a lot of cooling and a lot of heating done simultaneously. You can get to COPs of up to 6 with the way you kind of combine those technologies, which is exciting. So dual fuel heat pumps are also probably much more practical. We have 2 on a roof getting started up actually today, and we've got 2 more projects in the pipeline. What I like about this is that they are actually not more expensive than a high efficiency traditional uh, package rooftop unit. So a high efficiency package rooftop unit is about the same cost as a dual fuel heat pump. The dual fuel can either come in natural gas or electric resistance. I've been primarily focused on natural gas because I think that's probably best for the client long terms. But the heat pump can be used 95% of the time. as the heating source. And when the COP starts to drop and the temperature outside starts to drop, you can switch over to a more traditional form. So I think I'm most excited about this as far as a way that I could talk a, prag a pragmatic restaurant owner into making a switch towards decarb. It's not 100%. And a couple of years ago, I was pretty rigid on making it 100%, but I'm starting to kind of see the value of like making some incremental gains. And I do see dual fuel heat pumps as a real promise in that technology right now. I think that's my last slide, but I look forward to hearing what Matt has to say.
Thanks so much, Jimmy. Yeah, I really like what you said about incremental improvements, and I think that's something that we can dive into more later in our conversation. We're excited to hear from Matt, who drives sustainability initiatives through retro commissioning, monitoring-based commissioning, energy audits, and guiding buildings in achieving compliance with local building performance standards. Matt has extensive experience working with commercial, medical, industrial, and public sector facilities. His expertise lies in identifying and evaluating the feasibility of energy conservation measures to optimize building performance and sustainability. I'll turn it over to you, Matt.
All right. Yeah, thank you. Appreciate the introduction. So yeah, my name is Matt, studio lead for our sustainability team with Stantec. If you're not familiar with Stantec, it is a very large global A&E firm. So if you're thinking like AECOM, Jacobs, WSP, some of those names, you're probably on the right track. Next slide. So my technical background has always been in demand side energy services. So basically everything and anything to do with existing buildings, that includes energy auditing, a lot of the building performance programs that are coming out for different municipalities throughout the country. And then, I highlighted RCX and MBCX here specifically because that's always been my true passion. And luckily, I am talking about that today and, why I think that is very valuable for buildings to consider, regardless of your size, age, it it will it will work for a lot of different scenarios. So next slide. So I'm guessing a lot of people have gone through some sort of webinar in the past talking about retro commissioning and what it is. Feel free to read these bullet points, but just at a very macro level, if you think about anything on the capital side, like new equipment, rooftop units, chillers, boilers, VFDs, lighting, building envelope changes, I would put that all on the capital grid side. RCX is really about doing what you can with what you have currently. So visually, after an RCX analysis and project, your equipment won't look different, your building won't look different. But what we focus on is the efficiency of the operations. So regardless of the HVAC equipment, if we're looking at a pump or we're looking at a major plant, we're looking at like set points. We're seeing if your sequences are working according to the design. We're seeing if the design sequences that you originally implemented were even efficient to begin with, and maybe think about changing those. And then we also look at some small mechanical things that can have a huge impact. For example, just a temperature sensor, a humidity sensor, maybe an outdoor air damper, for example, is stuck open, right? So we're looking for small mechanical and optimization upgrades in your building that can be done without really going to the bank, trying to purchase large equipment that really reduces the barriers to entry because it's all there right in front of you. A lot of the stuff building engineers can tackle, and then if not, a lot of places do have a control contractor on staff or with some sort of agreement that we can get these things done. So next slide. Another really good thing about retro commissioning is that there are a ton of utility programs throughout the United States that fund this sort of analysis. They all do things slightly different. I think the ComEd program here in Chicago is one of the best examples, if not the best, that I've been a part of. So I think, for me personally, been really lucky working with the the ComEd program here. Just the way they're willing to fund things and work with us, it's been very impressive. So the nice thing about the utility funded RCX analysis is that they'll usually pay for the engineering analysis, and then they'll even fund some of the implementation costs associated with what I had mentioned. So if you need to go out and buy a new sensor, if you need to program a new sequence and do some testing around that, they're willing to pay some of that back based on the amount of savings that your building is receiving. I like this because it's very direct. It happens. We get to actually see the savings. It's not just sometimes you hand off an energy audit report and you think you do a good job, but it might get thrown in a drawer, or the whole thing was just for compliance. But RCX is a very data-driven process that takes it from investigation all the way through implementation and verification. So it is really holistic in that regard. Next slide. So to give it an example of what I would call a major success, we get 151 North Franklin here in Chicago. So for those of you that don't know, 35-story, 800,000 square foot building. It is one of the newer glass curtain wall looking ones. But one thing I wanted to note specifically about it is that this was constructed in 2018 and it came with all the bells and whistles. So talking about LEED, well, full DVC building automation system. We came into it with the building being Energy Star certified, and it even had a wired score. So on the surface, a very high performing building, right? And I think a lot of people expect old, dilapidated, maybe deferred maintenance buildings to be the best opportunities, and I think they still are. But this is kind of just to show that regardless of where the building is at in its age or life cycle, this can be a good opportunity. So, we can go to the next slide. And I won't have enough time to get into the specifics of the measures, but we did find a lot. And when we got to this building, things were operating according to the sequences that they were designed. So we didn't see sometimes you see things that are like scheduled incorrectly, or there's an override on a set point, or just something has been set a weird way and it's been forgotten about. We see that in a lot of older buildings. But in this case, what we saw in the sequences of operations matched the BAS. But we did quickly notice is that the building was really never tuned to the demand of what it needed. So whether you want to say they were overly cautious, or they just never really took a second look to see if their design matched what they were seeing with the performance of the equipment. And that's where we found a ton of savings for them. So, for example, they have a DOAS unit that serves floor-by-floor air handlers. So they have a single outdoor air riser in this building. And what we found is that they were overheating that just to cool it back down later on. As it got to the system, we found out that they were providing much more outdoor air than they needed to. So we actually ran through an ASHRAE 62.1 calc to confirm those appropriate levels. During unoccupied hours, they were heating spaces a little bit more than they needed to, and this is a building with triple, quadruple pane windows that are sealed perfectly, so the building retained heat very well, and we found out we could get away with a little bit more there. And just some other small items related to pump sequencing. We looked at their energy recovery systems. They do a really neat thing where they use heat pumps to take their bathroom exhaust air and they feed that right into the DOAS. So they're not only heating their DOAS outdoor air mechanically with electric heat, but then they're also using some waste heat recovery. But basically, we were able to just there was some programming that was required, but a whole lot of this was really just changing set points, using the existing control infrastructure that they had. So if you could go to the next slide, just showing the impacts of what they received annually. This was an all-electric building, so they did rely on electric heat. We implemented a total of 7 energy conservation measures. And the cost, which you can see right there, was actually covered by the program, which was great. Really, the only cost to the building ended up being the time that they invested with us to investigate these measures and see what they could do. And then post-project implementation, we did an analysis, and I think it's my final slide. But it's really just cool to see the payoff that this building received and what we found. This is weather normalized, so we did take into account, is this year warmer or hotter or cooler, sorry, than the previous year? And what we found is month over month, we were consistently, 10% roughly under what they would have consumed from an energy consumption standpoint in the previous year. So I can't say they're always as successful. This was a really good one. I think new buildings actually offer some more opportunities that older buildings don't, just because there are a few more barriers on like what you can and cannot adjust. But typically we expect around 5%. I think this one was closer to 10%, but again, just really want to highlight, this is something a lot of buildings can do. It is very quick, and there are very few barriers to conducting this sort of an analysis, especially when you get funding from the utility. So I definitely want to highlight that as something that makes a lot of sense. And I think that should be it. I'm a little over 10 minutes, but yeah, there you go. Thank you. Appreciate it.
Thank you, Matt. I think that's really helpful to learn about retrocommissioning and utility incentives and how we can leverage those. And funding and financing, I believe, is always a barrier that it's nice to have opportunities and strategies how to overcome that. So thanks for sharing. We're gonna turn it over to Maya now, who is a senior project manager working on Elevate's high performance buildings team, primarily supporting multifamily affordable housing buildings with green certifications and decarbonization strategies. With a background in electrical engineering, Maya brings both technical expertise and passion for sustainability into her work in affordable housing preservation. Over to you, Maya.
Thank you so much, Jim, and thank you to Matt and Jamie. I think they've really teed up some great conversation points, and I will be moving into one specific case study of an affordable housing project that Elevate is still in the process of working on, and it has been, quite a journey for us for electrification. So go to the next slide. Yep, next slide. Thank you. So just really quick to start us off a little bit about Elevate. We're a nonprofit organization, and our mission is really centered around the idea that everyone deserves clean and affordable heating, cooling, and water. So this is kind of the crux of what we do. We are mostly working in the residential space, and we also work with other nonprofit buildings on how to reduce their energy usage and electrify and decarbonize their properties. Next slide. Jim mentioned I work on our high performance buildings team. And so just to give everyone an idea of what that means and what our team specifically does, we kind of do everything from the very initial planning phase with large affordable housing developers or small local ones as well of any size, and then going all the way through construction and post-construction monitoring. So starting with looking at an entire portfolio and helping developers figure out where to target their decarbonization efforts, and kind of where to start, where funding might be available. And then at the building level, doing assessments and finding particular energy conservation measures, electrification measures, and renewable energy opportunities that really do apply to a specific building, and then going all the way through design and construction and supporting those initiatives throughout. Next slide. So the case study that I'll be discussing today is La Paz Place. This was a pilot project that was looking at multifamily affordable housing electrification in the Midwest. So the goal of this pilot program was to show that electrification in the residential space was possible and was beneficial to residents. So La Paz Place is a 3-building complex totaling 44 units. All of the units in La Paz Place are affordable at either 30% or 50% area median income. These buildings are located in the West Logan Square neighborhood. So for those of you in Chicago, you might know this neighborhood has been experiencing extensive redevelopment, gentrification, and loss of affordable housing throughout the past several years. So this project was spearheaded by Bickerdike Redevelopment Corporation. So they're an affordable housing developer in Chicago, and really they do focus on providing high quality affordable housing to their residents. And so this project was to show that electrification in these types of buildings, pre-war masonry, courtyard style, is possible and is going to show benefits to both the owners and the residents. Next slide, please. And I do want to mention that this, was a huge team effort. Elevate was part of the project team, but we also worked alongside Slipstream, ComEd, and DBHMS to tackle different parts of this project. So both the construction management and implementation, and then we're really in this post-project monitoring phase that I'll talk about a little bit more to see what the actual impacts have been compared to what we predicted. Next slide, please. So before I get into the actual scope of the project, we started working with Bickerdike, and we're going all the way from, the pre-assessment phase through the end of construction. And I really want to highlight the importance of the assessment phase in these types of electrification projects, specifically as they pertain to residential work. When you're doing a rehab of an existing residential building, you have tenants that are living there, like this is their home. And it's really important to make sure that they're not only involved in that process, but that their voices are heard, their concerns are taken into consideration, and that they're very much integrated into this entire process, because they ultimately will be the ones living with the upgrades that are made. So something that Bickerdike really emphasized was resident engagement. They really support their residents being involved in this process. And a majority of the La Paz Place residents were Spanish speaking. So something that Elevate incorporated into this initial assessment phase was bilingual resident engagement, which took a variety of forms, right? So that could be going door to door, kind of explaining what the proposed upgrades were, asking residents what their concerns might be. We found that there were a lot of folks specifically who are pushing back on the idea of electric stoves, right? Like so many people who have grown up using gas stoves, they really, really feel passionately about that. And that was a huge challenge to convince people that, you can still cook with an electric range in the same way. Like these are some of the considerations that might change how you engage with the equipment. And another piece too are cash incentives for residents who are actively participating in this project, right? It takes time, it takes effort, and it's really important that people are compensated, because ultimately they are an integral part of the success to this project. Next slide. So now moving into the actual scope of the project, we were looking at these 5 main areas to upgrade. I will mention that you might not see weatherization on here. That was done previously through a ComEd program several years prior, which Elevate had also been involved in. So the relationship with this building did run quite deep. And so we were really now focusing on the electrification measures. A lot of times you'll hear people talk about, starting with energy reduction. So looking at weatherization, energy efficiency, where those initial upgrades can be made to reduce the overall energy usage so that you can appropriately size equipment such as HVAC. And that should be reflective of an initial lower energy usage. So that was done in a prior phase. And then this pilot program was looking at implementing cold climate air source heat pumps, heat pump water heaters, non-induction electric stoves and dryers, and then adding solar towards the end. So, once you have kind of your whole electric usage laid out post electrification measures, then looking to offset some of that usage through solar. And that was kind of Elevate's approach to phasing this project. This is another thing where when you have residents living in a home, it's impossible to do every single one of these things to every unit at once. So prioritizing where to start also depends on things like seasons, right? Like, now would not be a great time to be replacing people's heating systems and having to have them, offline for several days. So really thinking about project timing and phasing was important to make sure that residents were still comfortable and not being very disrupted by the work that we were doing. Next slide. So this just kind of gives you an idea of the timeline for how this project was phased. So I mentioned that the energy assessment and air sealing and insulation happened several years prior. And then in 2020 was when we kind of kicked off the electrification portion of the project. And this project is still ongoing. So, there's still pieces that we're kind of tweaking and fixing as we've gotten feedback from residents. But now the entire building is heated and cooled by air source heat pumps, and the domestic hot water heaters have been installed. I believe that the solar process is still ongoing, but the design of it and initial analysis of savings has been complete. Next slide, please. So how are we evaluating the success? Oh, and sorry, I didn't realize there were transitions, so you can click through so that the whole slide, thank you. So how are we, gauging success of this project? So initially, in order to size equipment and decide how we were going to move forward, we did a utility bill and carbon analysis of all of the existing utility bills. And this helped us predict that certain units would actually not necessarily see financial benefit from electrification. So for those units, it was really important that we incorporate solar so that we offset that excess usage, and that they don't see higher utility rates. So for Elevate, this is kind of a non-starter. Like, we will not electrify a property if it's going to result in higher bills for residents. And then for the post-retrofit monitoring, we selected 9 apartments to look not only at annual energy usage and carbon impacts, but also cost impacts and indoor air quality impacts. So, by replacing gas stoves and improving ventilation, we really did want to see what the air quality differences were as well. And we are still in this post-retrofit monitoring phase. So if you are interested in kind of getting a deeper dive in the data that's been available and that's been analyzed, I know Elevate's website has case studies for La Paz Place. And since I'm over my time, I will stop there. I think the next slides about lessons learned and kind of the initial analysis results I've mostly covered. So I can go ahead and hand it back to Rimjim. But if people are interested in knowing more about this project, I'd be happy to connect.
Awesome, thank you. Yeah, if you want to go through those slides, Maya, you have time. Don't worry about it. I think it's interesting to just go through those numbers, and I appreciate you talking to the evaluation and the analysis results as well, because that's a key piece of the decarbonization process. So go for it.
Okay. Oh, great. Thank you. If we could go one slide before this. So I'll just touch on some lessons learned that I haven't talked about yet. A lot of these revolve around resident training and engagement once equipment's been installed. So, for example, like thermostat settings, people aren't used to a new like smart thermostat or even a programmable one. So making sure that they're able to use these in the most efficient way possible and not, having the heat on high when nobody's home, right? So just kind of things like that might seem intuitive, but if you're not used to a new equipment, it might not make sense. I mentioned the part about solar and how it's really important to consider that if electrification is going to raise bills. That goes for both the owner and the residents. We did see in the common areas that the electrification measures weren't necessarily going to benefit the owner paid meter. And that's because, for each individual resident, like they receive a reduced bill for their gas disconnection fee. So, there's just like a set fee for having gas service at all. But if you're only applying that to one common area meter, then you might not see as much of a benefit there. And then, so the solar installed is intended to help those selected units that we're going to see higher energy bills, and then also the owner paid bills. Involving the electric utility sooner. This is really important. I know we've had so many project delays. La Paz Place, was one, but even throughout projects we do in other states and in other utility territories, there's so much back and forth that has to happen with the utilities when you're electrifying. So making sure to involve them sooner, understand the metering requirements, that's really crucial. And then, yeah, considering, you know, the time of year that you're implementing, that's also really important, just like I mentioned before, so that residents can stay comfortable while the retrofits are ongoing. And then next slide. Yeah, so these are going to be the modeled utility impacts. So both carbon and energy usage and costs were modeled here. So this was the total savings that included, well, yeah, with no solar, and then post retrofit costs with solar. So you can see those percent cost savings would not have necessarily been beneficial for the common areas, and then for some residents as well, if we hadn't elected to install solar. And like I mentioned earlier, for the post retrofit or the post monitoring results, there are some case studies on Elevate's website that kind of go into this in a lot more detail. We've had folks on our team working on this for several years now to really get an understanding of, you know, how this can be a case study for other multifamily affordable housing buildings in the Midwest. So yeah, I will wrap it up there. Thank you, Jim.
Amazing. Thank you so much. That was really interesting and a lot of great numbers. Since we are still talking, since you just finished talking about La Paz, there's a question from Aaron Stash. What did you learn from the La Paz heat pump water heater system, and what would you do differently in the future? Economical centralized HPWHs still seem problematic in our climate.
Yeah, so that's one that has been a challenge, and I know the post monitoring results have reflected that. And they did end up doing individual heat pump water heaters. So the original system was central, but you know, we haven't found a great solution for a central heat pump water heater system yet. And you know, there have been projects where we've tried to think about how we could make it work, but it is really difficult. So for now, when we recommend electrifying domestic hot water, we usually do recommend individual heat pump water heaters, which is more beneficial for buildings that already have individual water heating units. So this was one that cost was a lot higher than we had anticipated. And, you know, we did kind of have to redirect the design direction once we came to that conclusion.
Awesome. Thank you. I hope that answered your question, Aaron. And if you have any follow-ups, please feel free to put them in the Q&A. And I saw, Jamie, that you answered Paula's questions. Thank you. But I just wanted to give all three of you a chance to add anything to this, or if you had any other thoughts, Jamie. Assuming the change from steam boiler to electric heat pump will require change from radiators to forced air heating, how have you dealt with addition of ductwork to old buildings, especially larger old buildings?
Yeah, so from my experience, which is, you know, not as in depth as like a mechanical engineer and architect, we have put in VRF systems to heat and cool, and VRF systems don't actually require ductwork the way like a traditional HVAC system would. So it does require miles and miles of copper and electric running through a building, which is a change. So in the example I gave with Oak Park Temple, we had to core through holes. I think there was like 172 holes drilled through parts of this old structure, a lot of which had old electric within it that we did not know from the design plans. And so we had to run all the electric. So you don't have to have large ductwork going through it, but you do have to have small, you know, 2 to 3 inch holes for copper and electric running throughout the building. So that is a change and a cost. But on top of that, for modern code, you have to have good fresh air. So that is the VRF system provides heating and cooling, but it doesn't provide ventilation. So you have to find a different way to ventilate the space. If you have existing ventilation, I haven't seen a ton of examples. I just see a lot of old boiler buildings with like something that they don't understand that's been closed that used to provide ventilation and no longer does. So in that case, you do need to provide fresh air to the space. And typically by code, you have to get to each space, and that does involve ductwork. So VRFs do not require ducted sources, but if you want to get fresh air, you do need to. And we use energy recovery ventilators for that purpose in both of our projects that I showcased. And the benefit of that is that as energy is leaving the space, as air is leaving, it's controlling it, pulling the heat and the moisture out of it, transferring it to the incoming air. Sometimes as high as 93% of the energy can be recovered. And so if you can do that when you're looking at the overall, the mechanical engineer designing the space, you can, instead of 10 units, you could put in 8. Instead of, 5, 10 units, you could put in 5, 7.5, 10 units. So it does have a big design cost, but itself does have a huge cost in finding ducts to get them into the space and throughout the space.
Thank you. Matt, I know you shared an example of a newer building, but did you have any thoughts on this as well?
Sorry, I don't even remember all the details of the initial question. If you could repeat it really quick, though,
Yeah,
I'd be happy to
sure, of
help.
course, no problem. Assuming the change from steam boiler to electric heat pump will require change from radiators to forced air heating, have you dealt with addition of ductwork to old buildings, especially larger old buildings, and how do you deal with that?
Oh yeah, I mean, I would echo what's been said. I think it's very challenging. It does add a lot, and one of the issues with older buildings is a lot of stuff is, so to speak, locked in, or there would be a large financial investment to completely, yeah. If you're talking about VRF from, maybe you have packaged RTUs, and you can find a way to use some of that existing duct work for ventilation, but yeah, it's certainly not an easy task. So. Fortunately, I don't have too much else to add on it, but that'd be my take.
Awesome, thank you. And I can see, Maya, that you're answering that question. So I'm just gonna invite everyone in the audience to post more questions if you have any, while we just go into a bit more of a discussion with our panelists here. So when you assess an existing building, and to all three of you, how do you typically prioritize upgrades like HVAC electrification or insulation or solar? And what should owners focus on first to get the biggest emission and cost impact?
I'll start there. I think one of the interesting things in my experience is going into a building that people will say, like, I want to put solar on this rooftop, and I'm a huge solar advocate. But they have not done any of the low-hanging fruit on the inside to bring, like, people shoot for the moon before they even look what's realistic. And it is very difficult, I would say, to find a vendor that can do lighting, HVAC, think about the building envelope, the roof. Like, these are very comprehensive solutions that are hard to find. And I don't think the utilities quite nailed it in how they support and grow companies that can provide that. But I would say, like, people should start, like, if someone's making a recommendation and the payback is really fast or the utility supporting, you should really consider it first. But of course, I'm a full advocate of solar and everything. Decarb, it's just that we need to kind of walk before we can run sometimes.
Yeah, I'll add to that too. When we kind of do building assessments and make recommendations, something we really prioritize too is equipment age, right? Like ideally, you go through the energy efficiency and weatherization, and then electrification, and then added solar. But if you installed gas furnaces that are highly efficient, and that was a year or two ago, then it doesn't make sense to replace that new equipment with a heat pump at this phase. So something we've started trying to implement is what we call like a zero over time strategy. So looking at how you can get to this endpoint of electrification or decarbonization, but where to prioritize initial efforts and like capital plans based on existing conditions.
Yeah, I'll add. I think the two big things you can do, or if you don't have a capital plan, get one, and if you do, to refine it and really understand it, and just as much data you can get about what options are available to you. It's really important, like, I mentioned RCX. If you're going to replace your BAS at some point, maybe that's not a good idea, right? So like there is things that have kind of a cascading effect on buildings and building systems, and it's important to, yeah, like Jamie mentioned, you want to tackle the low-hanging fruit. Like if you don't have LED, for example, yet, like you do that now, right? Before we get into the really complicated stuff. Yeah, do a retro commissioning project. If you have old equipment that you are need to replace, focus on that and then just make sure that, what you're doing doesn't retroactively go away at some point if you are considering major capital upgrades. So everything needs to be considered anytime you touch any building system, in my opinion.
Thank you. And you touched a little bit on RCX and a little bit about how the ComEd program and the utility programs are really helpful and some of the best programs in the nation. So I'm wondering, we've heard from a lot of people in our audience that financing can be one of the biggest barriers in people pursuing any improvements or decarbonization projects. So any funding sources or strategies that you think that people should explore early on that make sure that they're not leaving money on the table or they might not be aware of can be used to pursue a lot of these improvements and capture that low-hanging fruit.
I guess, yeah, I can start off on that. Utilities, especially like ComEd, like their goal is to provide funding. They need to. I mean, a lot of their metrics are based on them doing that. So they want to support, and there are people available to help guide those decisions with it. If it is within the utility, if you are like in certain communities, or even if it's like a public sector project, with Elevate might be able to talk a lot more than I ever could about that. But the important thing I've seen on my side is that when you are looking at funding opportunities, especially on the utility side, most utilities do need to show cause that the incentive is the reason or a driver for you completing a project. So before you touch anything in your building or buy new equipment or sign a contract, I always recommend before you do that, check off all the boxes, go to the utility, fill out the applications, get that squared away, because they might not honor that if you are in progress already with something. So I think that's very important, just to be out ahead of it and make sure that you've looked at every opportunity before things really get rolling.
I'll chime in on that, and then I actually have a follow-up question for Matt about RCX. But I think the best thing we can do as an industry is get back to basics. I think the funding is such a support to move us forward, but like we won't move everyone forward in these buildings until it's truly return on investment driven, payback driven. And I think our industry, it's just criticism of all of us, but of myself as much too, has gotten too dependent on growing businesses based on rebates. And like we've seen that as federal legislation changes, like we then our businesses go away or they weaken. And so if we can build our businesses based on like true value and it's there, like a 2-year payback is amazing. It's a 50% return on investment. Any investor would love that. So anyways, to Matt, the question is your example of that study, like $60,000 of savings. Does Stantec, and do you find that you like that same building asset owner will do that and they'll pay for it in other locations without the support, or it's a real uphill battle to sell that?
I think you nailed it. The answer, most of the time, in my opinion, is no. There have been some independent RCX projects that we pursued, but when it is there, and we see this with energy audits as well in Chicago, it kind of, you can't compete independently when that is, the utility programs, which I think I want to clarify. I'm happy they're there and are extremely valuable, but because they exist in the way they do, can kind of control that market. So it is difficult, or it does make it seem less reasonable when those types of funds aren't available, just because, like, especially in this territory, they have been for a long time, and people kind of rely and they come to expect them, right? And then if they're not there, even if it's still a good project and it makes sense, just knowing that that support isn't available can sometimes be a deterrence. So I do think it does frequently happen.
I can chime in. This is going to be kind of specific to affordable housing, but one thing that we've really seen driving a lot of our work is tax credits. So low-income housing tax credits are an essential part of the funding stack for any affordable housing development. And a lot of states, including Illinois, have added a sustainability component that either makes your application more competitive or a certain like baseline certification is required in order to get tax credits. So, I mean, at the policy level, like, I think states making this a priority and a requirement has really driven the market towards, like an Energy Star certified affordable housing building is just kind of standard now, right? And by making it really crucial to get those tax credits in order to fund your project, that drives sustainability. And I think if that is a requirement, engaging a consultant early on to figure out what path can be taken, what's the most cost efficient way to meet those requirements while honoring the intent of the programs. Doing that early kind of sets up your budget for success, and there are no surprises that come down the road when you're at CDs and realize that you have to get a certification that you're not prepared for. So yeah, that would be kind of my 2 cents on that.
Thank you so much. We're closing in on time, so I'll just ask a final question for all of you, just a quick reflection, thinking about any successful retrofit or decarbonization project that you've worked on. What is one lesson that you think everyone should know before starting on a project?
I'll start because this is an area I feel super passionate about, is that don't pay attention to the dollar today as much as you pay attention to the dollar over time. Like so many projects, the utility rebates cover the full cost in certain examples over the last 10 years, and people do that work. And I can't tell you the number of times I've gone back to a client who did that, and now they've got way overlit spaces with poor controls that don't work, and they're going to have to spend that money again. And in the last 5 years, they had a free project 5 years ago, but in the last 5 years, they've actually spent a lot more money on utilities, and now they're going to have to spend the money again to fix the problem. And so any project, decarb, EV chargers, sustainability, weatherization, roofing, it's not just the dollars you spend today, but it's the dollars you spend over time is really, really critical.
Oh,
I'll
okay.
Sorry.
No, you're good. Yeah, I would say that, it's a huge team effort in order to decarbonize and like maintain operations of a sustainable building. So getting as many stakeholders involved as early as you can is huge, right? Like this impacts residents, building operators, property management, the whole design team. So making sure like those goals are laid out to everyone who's going to be impacted at the start really sets up a project for success.
I think this is especially applicable now in a post-COVID world, but we see a lot of buildings that are at some level of uncertainty, whether we're talking about even if maybe they want to sell the building, if the building is in receivership, if it's changing property managers, if the building engineering team is moving on. I mean, there's so many different things that can happen, and it kind of like stalls a lot of progress. They're like, we don't want to do anything right now because we don't know what's going to happen. Like we might switch contractors. I mean, it could be really anything, but like to try to not let that distract you from the low-hanging fruit that is available in your facility and that you can take advantage of anytime, and it often does have an immediate payback. So just keep your eyes on that and never lose sight if there are distractions.
Amazing. Thank you, Jamie, Matt, and Maya, for sharing your insights and for sharing your time with us this afternoon. It's been really enlightening and great to have you all on this panel. I'll just ask Matt to pull up that last slide so I can share a little bit about how people can stay engaged with the Hub. But this is going to be our final webinar of this year. Thank you all for joining. We'll be back in 2026 with more programming. You can check out our website, our resources, sign up for our newsletter so that you keep receiving updates. The Building Energy Pod will keep dropping new podcast episodes. And if you want to share your projects and your work with us, please drop us a line as well. Follow us on LinkedIn. There's many ways to stay connected with us. Appreciate you all joining today. Happy holidays and Happy New Year to you all. Thank you.